Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's webinar is Performance Tuning of J2E Application, Simplest and Most Effective Ways to Tune a Java J2E Enterprise Application. Our guest speaker today is Mr. Satyarth Gaur, Senior Consultant at Wells Fargo India Solutions, Bangalore. Satyarth Gaur is currently working as a Senior Consultant at Wells Fargo India Solutions. He has almost 7 years of experience in design, development and implementation of Java and J2E applications. His last assignment was with Dell Pero Systems, Bangalore as a Senior Consultant. He is also planning to launch one of its kind Dr. Java Clinic in Bangalore on complex Java and J2E topics. So without further delay, I introduce you all to our guest speaker, Mr. Satyarth Gaur. Over to you, Mr. Gaur.
Hi friends, so today's agenda is about the performance tuning for any Java J2EE applications. See, to become a performance tuning expert, we all need to see the holistic view of any Java J2EE application. By holistic view, I mean the view how your J2EE application interacts with different components. So your J2EE application is a web application, but it has different components. It interacts with hardware, it interacts with a web service, it interacts with a network, it has a database component, it has a service layer, it has a front end. So we need to tune all the layers of a J2EE application so that the overall performance is enhanced. So we need to focus equally on all the layers of any web application in Java and not on any particular layer. So we need a holistic performance view. We need to see and analyze and tune it in the fastest possible manner. So without any further delay, we will see the different layers of J2EE application and how we can tune them in the most practical manner. I am not going by any bookish knowledge. It's more of a practical from my past experience. What I have found you to be useful, I am sharing you those tips and tricks. So first is tuning of your application layer, that is the application itself. So here we can tune our code, we can optimize our code, we discuss all this. So let's see. See, one of the most important aspects is if we do a proper garbage collection, that is one of the keys to tune your application. So the idea in this is to reuse the existing objects, avoid creating unnecessary objects. So sometimes we have a habit of using new operator a lot. We should avoid using lot of new operators and try to reuse the existing objects as much as it is possible in our Java classes. We should try to create something like object pool, string pool, and so on. And also we should avoid using explicitly the garbage collector by calling system.gc or runtime.gc, because this degrades the performance. This has been found in the research. So second is using the static keyword as much as it is possible. So try to use static methods, try to use static keywords, because you know that static variables, if we use them, it makes the performance faster. So but remember that you cannot use static methods everywhere, only when there are scenarios like you have a method and you need to access that method without creating an instance of that class, like a utility method, a generic method, which you want to share across all the layers of an application. Such methods you can make it as static, and this improves the performance because you are not creating an instance of the class. So why to unnecessarily create an instance of the class when you can have utility methods in a static method? So, but remember that static methods cannot be overridden. So use static keyword with care. So it helps the JVM to optimize a static variable faster than a normal variable. Use of correct parser in our programs. See, there is a lot of debate about whether we should use the XML data at all or not. See, suppose I have a static data. I can always keep that data in a properties file. I can keep that data in a static XML file. I can keep the data in a database. So you have to analyze your scope of the application. Where do you want to keep the static data? Suppose you want to keep the static data in an XML file and you want to load that XML file when you start up your program. I mean, when you deploy your web var file or a ER file in the web server or the application server, you restart the server. At the time of startup, your XML file which contains the static data should be loaded. Now, which parser to use to parse that static data and convert that into a Java object? So, it has been found that in general, for large XML files, we use text parser because a DOM parser occupies a lot of memory. So, for of course small XMLs, we can use DOM, but in general, it's a good idea to go for text parser because it saves the memory and it's faster to process a very large XML file containing some static data. Of course, it's your choice. You might not want to use the XML file at all. You can keep your static data in a database, but then you have to hit the database every time and fetch the data. So we will discuss about the data caching. See, caching of the data of course improves the performance, but at the same time there are memory constraints. You cannot keep on caching the data, you cannot keep on caching the objects to an infinite limit. There is some limit. So whenever you are using any object or a session variable as a cache to store your static data or to store the data which is less frequently changed and which is more frequently being accessed, such data you have to identify and keep it in a cache. But every time remember that you have to keep on updating the cache whenever there is any changes to that database table. So otherwise you will have dirty reads and unsynchronous information. So keep on updating your cache every time you make a DB update, and you can always share your cache object through different layers of your application. You can also utilize the browser caching. See, for the first time when you log into a web application, you can store the URL, username and password in a browser cache, so that next time the URL or the web application identifies you or the browser identifies your credentials. So you need not authorize yourself again and again. Just authorize yourself for the first time. This improves the performance. Writing an intelligent or an optimized Java code to improve the performance. This is one of the most important aspects of performance tuning. One of the aspects is you can always change the storage location of the data based on the frequency of access or based on the access pattern. In the following example, you see I have two for loop, but in the second for loop, just by changing I equal to limit, I am starting from the reverse in the descending order instead of the ascending order. I am going in the reduction from limit to limit minus 1, limit minus 2 and so on till 0. This improves the performance. Because see, it might happen that my data is lying more towards the right side, I mean towards the limit rather than towards the left side, that is towards 0. So suppose, why to unnecessarily scan the entire information from 0 to limit when you know that your data is more frequently lying in towards the right side. So by knowing the position of the data, you can change your for loop and you can improve the performance. This is one of the examples, and you can apply this logic or this trick everywhere. Using selective import. Many a times we have a bad habit of using the entire package .star instead of importing the appropriate class which we only want to use. So you have to use a selective import. Reusing the existing code. It's very important to refactor your Java code and try to write as much modular code as possible. See, whenever we use any framework like struts and Spring, the objective is loose coupling. So if your program or the modules is loosely coupled, then in general it has been found that it improves the performance. since it reduces the complexity, and hence even the queries complexity of the query will be reduced if the complexity of your code is reduced. And when the complexity is reduced, of course the execution time also reduces, because you have to do the less interactions to get the same result. More the interactions, more the execution cycle, and more the time consuming process it becomes. Using string buffer instead of string objects. See, whenever possible, try to use mutable objects which can be modified. If you are using immutable objects like string objects which are not modified, whenever you try to modify it, it always creates a new string object in the memory. So it is memory consuming. Don't try to create unnecessary threads and temporary variables. We have a bad habit of using lot of temporary variables or intermediate variables. Sometimes we declare some variable which we are hardly using in the entire program. We declare some variable, we initialize it, and we are not using it. So do away with that habit. Try to refactor and optimize your code. Again, avoid excessive writing to the Java console, system.out.println. It's a bad habit. It degrades the performance. Use only loggers and sysout whenever it is really needed. Data types. See, using correct data types can of course increase your performance. Sometimes we try to use long when we can use int. So try to use that data type which occupies the shortest space and which can solve your problem. If an integer can solve your problem, why to store the value in a long? So an unnecessary casting should be avoided. It's a bad idea to use long variable and then again cast it into a string or an integer by using integer.parseInt or directly typecasting it, because typecasting operations and all this casting takes a lot of memory and time. It degrades the performance. So just use what it is needed. If you use integer, if you want to use integer, just use that. Try to use static final keyword while creating the constants. See, instead of hard coding the constant in multiple places in your Java code, try to use a static final constant, declare it on the top of the program, and try to reuse it. So whenever you have a data which is invariant, which is not going to change in the entire life cycle of the application, declare it as static and final. Of course, you can always keep that such data in a properties file also. But again, loading the properties file, reading the property, it is time consuming process. Whenever possible, declare your methods as final. So it has been found that final methods are going to improve your performance. But remember that use only final methods when you don't want to override that method, because those methods cannot be overloaded. So there are constraints with final methods. But it is found that JVM, whenever it finds a final method compared to a method which is non-final, final method is processed more faster. The research has proved it. Try to validate all input data as close to the client side as possible. Why to unnecessarily overburden your server with validations? Try to do the maximum validations as close to the client or the front end, and leave the minimum validations or those business validations only for the server, because we don't want to unnecessarily burden the server component or the server side. So this will improve your performance. Remember that static include of a JSP file is always faster than a dynamic include. So whenever you are including different JSPs in a single JSP, try to use static include. Finally, use of tools like JConsole, JProfiler, JProbe, Programming Mistake Detector, PMD, and Find Bugs. If you configure these tools in your Eclipse environment or a NetBeans environment, whatever environment you are using, with these tools, you can always know and monitor your thread creation, object creation, memory creation. You can control these variables. and you can optimize your code in a better format. You can know what best practice your code is lagging, or any bad or anti-pattern your code has. So these tools are very, very helpful, and you should configure them when you are designing at the start of the development phase in any Java J2E project. Preferably, PMD and find bugs are must these days. Try to minimize the data stored in your HTTP session. See, you should only use HTTP session when it is really needed. When you want to transfer a data from one layer to another layer, keep a low session timeout. It's a very bad habit to keep a high session timeout. Normally the industry standard is less than 30 minutes because performance effects. So try to minimize the data, store only that data which is really needed, and try to flush the session. Try to invalidate the session. Session.invalidate, session.flush. Use such type of syntax and try to constantly update and flush your session and keep a low session timeout. But don't overload your session. Don't keep high or large volume of data in your HTTP session. It degrades the performance for sure. It will give out of memory error. Disable the session creation in JSP if not needed. See, we can always write the syntax that we can disable in the JSP. We can write like session creation as false, so that unnecessary sessions are not created in JSP by default. So we can disable the session creation. So it depends on your requirement whether you want to enable the session creation or disable the session creation for your pages. Some pages may need to have session creation because you want to share the data, store the JSP data in a session and transfer it across different layers. So it depends on need basis. Efficient data storage. See, we all deal with high volume of data. We cannot remove our data. We need all the data to be displayed in the presentation layer. But we can always use Java compression techniques to compress and decompress the data. We can zip the data, we can store it in a session, and then when we are retrieving the data from the HTTP session, we can use unzip. So compression and decompression are part of java.util.zip package. You can use it, try to compress your data, create a .zip file, store it, that contents in a session or wherever, and then at the time of retrieving in the presentation layer, you can unzip. So this can certainly improve your performance. See, the amount of data you cannot reduce, but the amount of data storage format you can always change in a zip format, and you can save the memory or the disk space. There is another example. You can encode or decode the data. You can use base 64, base 32. See, you know, suppose you have a string str. I can do str.getBytes in brackets UTF-8 or UTF-32, UTF-16, ISO. Such type of formats. My basic objective is to reduce the storage size or the storage memory for that string, so that my string is stored in a more optimized format. I save the memory, I save the space, and I get the performance tuning. So try to encode and decode the data as I'm showing in this example. You can use different classes like base 64 classes. You can use base 32 and so on. So any encoding or decoding format you use, but make sure that it is really giving the benefit of reduction in the storage space. The size of the data, original data, should be reduced during encoding. Now, database layer tuning. See, in every application layer, we have a DAO layer, data access object layer. Whether I am using Hibernate, whether I am using Spring JDBC, whether I am using plain JDBC, there are some thumb rules where you can always tune your database layer. See, whenever you are using any select query or a Hibernate query, try to mention only the required columns. We have a bad habit of using select star from table. Don't use star. You can use the columns which you want to really fetch. This will improve the performance for sure. You can always optimize your query. You have tools like Query Analyzer, Query Optimizer, which can optimize your query in one shot. Basically, the objective is to reduce the number of joins. Joins are expensive. They degrade the performance. So try to optimize your Hibernate query or SQL query. Try to use prepared statement. They are pre-compiled. So it depends on the need basis. So suppose you are using a statement which is being frequently used, repeatedly a number of times. You can use a prepared statement in your JDBC. Whenever you create any statement object or a connection object in your DAO layer or a Spring JDBC code, try to close or flush them in a finally block. Make the statement and connection objects as null. Making them as null in the finally block makes them eligible for garbage collection. Try to cache as much of data as you can. Suppose you have a data which is being required by different screens. So every screen will try to fire a select query. Instead, fire a select query one time, fetch the data, cache it, so that successive screens may reuse that cache instead of directly using the DAO layer. So try to reduce the number of JDBC calls. See, you can use different design patterns like singleton pattern, JDBC connection pool. This way you can optimize your number of JDBC calls. So suppose you have a singleton pattern which gives me a connection object. What happens like if I have a class which returns a connection object of Oracle? I'm using an Oracle database. Now all the requests or all the screens or JSPs or resources will try to ask, hit that class and get the connection object. This will degrade the performance. Instead, I can use a factory pattern or abstract factory pattern or a singleton class which gives me a static singleton connection object. So it is a one time, it hits the database and gets the connection object. Now this connection object is a singleton object and it will be shared by all the threads. So all the threads will not create their own connection object. Instead, they will share their singleton connection object. This will improve the memory. Similarly, we can do the connection pooling and try to say when the application starts up, I already create a connection pool which has 10 instances and I am reusing and sharing those instances. This way I am hitting the database less number of times. I am reducing my JDBC network calls and I am improving the performance. So next we come to the database tuning or the database server tuning, RDBMS tuning. How to tune the database in general. See, database can be tuned. The most effective way is creating index over the table whenever it is required. Don't unnecessarily try to create an index. See, there may be some tables which has just 100 rows or few hundred rows. So there is no much benefit in creating an index over such tables, but there might be some table which you know in the future it is growing in size. Today it has 1000 rows, tomorrow it may have 1 lakh rows. On such tables, identify those columns, say primary key column or those columns which are being frequently used in the where clauses in the select queries. So try to create an index over those columns. The first idea is to identify those tables where you really need the index. And in those tables, over which columns I need to create an index. So these two are important points you should remember so that you effectively get the benefit of creating an index and get the performance tuning. So, like you have a scanning operation, a search operation, sorting operations. In such cases, index makes the life faster. Proper DB design. While starting the project, we are always told that draw a good entity relationship diagram. Understand the entity relationship, try to have a good database design, and do a proper normalization. But sometimes what happens, in the process of normalization, we try to remove the redundancy, we try to reduce the duplicacy, and we are trying to reduce the complexity by breaking a large table into smaller tables. In the process, we create n number of tables, and now we cannot manage those n number of tables. Because now suppose I have a select query, research has shown that whenever we have a query which involves lot of join operations, it degrades the performance. So the thumb rule is that whenever your select query involves more than 6 tables, try to denormalize the table. Try to reduce the number of tables so that you reduce the number of joins, table joins, and thus you improve the performance. So always normalize, but to a limit with intelligence. Don't over normalize your DB design. Whenever you have scenarios like batch operations or batch jobs, it is a bad idea to create SQL queries. Because see, an SQL statement, it will be compiled every time and then it will be executed. So total time is compilation time plus execution time. Whereas stored procedures, it can club all those SQL statements in a single stored procedure. They are compiled only for the first time, and for the successive times, they are directly executed. So you are saving on the compilation time. That is why in general we say stored procedure are faster than a plain SQL query in general. So it depends on a case-to-case basis. If you don't have a batch operation, you have a simple select operation, you can always use a prepared statement. But if you have a set of operations which are being executed, say a scheduler, which is the task which is being executed every day at 12 o'clock. In such scenarios, don't overburden your JDBC or a DAO layer with writing lot of SQL statements. Try to give that headache, remove that headache from the application layer into the database server by creation of stored procedure. See, of course, sometimes we get the idea, okay, let's use the views when we are dealing with n number of tables. Normally 4 to 5 tables or more, we create a view. But remember that view takes memory. View is basically an object which takes memory. Even though it is like a virtual table, but it takes memory. So unnecessarily don't create your views. Don't deal with views unless it is really needed. Because the research has shown that if you query for a data from a view, it takes more time than querying for the same data directly using the select query from the table. So using lot of views degrades your performance. But of course, the idea of a view is to reduce the complexity. So views are typically used to simplify and hide the data complexity, simplify the schema, improve the security by restricting the table access. But remember that view is basically an object. It occupies space. So don't overuse it. Now tuning of the application server. See, we might use a web server or an application server, but we have to configure it in such a way for our application needs. See, my need can be different from the other company needs. So let's tune the application server or a web server to get the best result, to get the best out of it. There is no definite thumb rule, but let's see some best practices. We can always increase the JVM size of the application server. Sometimes my application server does not respond in the desired time because of out of memory error or a perm gen space error. Normally we get in the Eclipse or the NetBeans perm gen space error. So in that scenarios, we can increase the JVM size. We can do the same for WebSphere, Tomcat, WebLogic, or for any application server. The basic idea is we can use the minimum and the maximum keyword. Like if you see in the example, I'm showing for the Tomcat. If you see in the second line, setting Tomcat heap size, you can directly open the Tomcat server console and in the arguments tab, just write -xms and -xmx. That is the minimum or the default, and mx is for the maximum. So here it is 64 MB and 256 MB. I can also do like minimum is 1024 MB and maximum is 2048 MB. Because normally the JVM heap size, the limit is up to 4 GB for 64-bit and 2 GB for 32-bit processors. So you can go up to 2 GB or 4 GB. But remember that there is a limit to the JVM heap size, and because the processor or the JVM needs to perform other tasks, you cannot give all the memory of the JVM to your application server. Then what will happen to the other resources like network or say web service calls or third-party calls or whatever like. This is an example for WebLogic admin server, how you can manipulate the JVM size. In case of WebLogic, there is a file called setDomainEnv.sh. In this shell script, you can always edit it and increase the minimum and the maximum size of the JVM. In this case, suppose I am using the Sun JVM, so I can use it like this. So try to open this file, setDomainEnv, and edit these values. Sometimes when we are designing a Java J2EE application which is working in a clustered or a distributed environment, and I know that my application will serve high volume of users, suppose a banking application which is doing millions of transactions per day, I cannot rely on one server. I hope the audience will agree with me. You cannot rely on one server. So you have to have some clustering in the server, or you have to have some load balancing in your server. Suppose 1000 requests are coming. I will design some algorithm where the first 500 requests will be served by server 1 and the next 500 requests will automatically be diverted to server 2. Or suppose if a server 1 is taking more than 1 hour or say more than 30 minutes to respond to a request, automatically that request will go to the next server in order to reduce the load of the current server. So how do we enable the clustering in a Tomcat? Same way we can do in WebLogic, WebSphere or JBoss. Let's see the Tomcat example. Go to the server.xml file. There is a tag called cluster. Uncomment this tag. By default it will be commented. So uncomment this. Then there is a tag called context distributable equal to true in the same server.xml file of Tomcat. You uncomment this tag also. Then in Tomcat server we have a file called httpd.conf. In this file you modify the name of the algorithm which you want to use for clustering and load balancing. I am not going into much depth about clustering and load balancing, but the idea is making some changes in the server files. You can enable the clustering capabilities of that server so that it can better handle your distributed applications. The basic idea is that the session replication capability should be enabled so that your session can be replicated between different servers. Say there are 10 servers and there is a load balancer which has some algorithm. So all the servers, once the session is created in one server, it can be replicated or transferred to other 9 servers so that the load is shared and the performance tuning is achieved. Now, apart from this, I have not covered many more things which I would like to discuss now verbally. So, see, main thing in the performance tuning is that you need to know where to tune and how much to tune. Suppose like there are scenarios where my CPU usage is very high. Suppose the percentage of my CPU utilization for my server is exceeds say 70 to 80%. Then I should understand, I should get a warning that it is a time to tune my application server first and then later tune my database and then application code when the CPU usage is very high. So it depends on scenario to scenario, circumstances to circumstances. When you deploy your application in a production environment, the nature of issues you need to analyze, and then you have to take a decision whether to tune the application server first or to tune the database server first or to tune the code itself first. So because the ultimate idea is we all want to have a low response time. Our JSP should load faster. So in spite of my server handling large volume of data, I want the low response time. See, the basic solution is we can always scale up the hardware, but it is a costly solution. I cannot increase the RAM, I cannot increase the hard disk, I cannot increase the CPU to an infinite limit. There is budget constraint. In such scenarios, your application performance tuning tips and tricks come helpful. So basically application tuning is an art. You should see the holistic view. All the layers must be tuned. There may be an operating system level problem, web server, application server, database server, or the code itself. All the components you have to optimize. Suppose you are using Hibernate. I can always use the Hibernate L1, L2 cache or the JBoss cache in Hibernate to cache my data, to cache my query objects, so that it is reused again and again. So the reusability should be promoted in the application design. So sometimes people say that, okay, let's try to create an index over all the primary keys or all the foreign keys. So you cannot blindly create an index. Understand that index also has a database overhead. So use only index over those tables which are really big and on those select queries which are being frequently used in your application. So try to make your code as loosely coupled as possible. There is one more basic scenario, because we all deal with lot of queries. We try to use lot of statements or prepared statements. So try to group all your search queries. Suppose I am creating a search module or a search page. I will try to combine all my related search queries in a single JDBC call. See, the basic idea of performance tuning in DO layer is to reduce the number of JDBC call. So let's club all the select queries in a single JDBC call, combine and make a single select query and fire it, rather than firing 10 small select queries. So this is one thing, and so there are many such practical things, like you can always remember, suppose you have a very big code and you have very less time to do the performance tuning. Then what you will do? You can always use the Pareto principle or 80-20 rule, which says that try to focus on the correct code to optimize. So suppose it says that improving the performance of a method that is called 1000 times and takes 1/10 of a second on average is better than improving the performance of a method that is only called 10 times but takes 1 second each call. So try to identify those methods which are being more frequently used throughout your application and try to optimize those methods rather than optimizing the entire code. So you have to identify what to optimize first. You have to define your priorities. So this is one thing, and try to see the basic idea of performance tuning again is first reduce the complexity of your J2EE application. Like we say, we try to separate the controller logic from the business logic always. Why? Why we introduce design patterns? Because if we reduce the complexity of a J2EE application, the number of interactions is reduced. The amount to retrieve the same data, the amount of time taken is reduced, and hence we get performance tuning. So in case of application server tuning, I am telling some generic things which can apply to any application or a web server. See, every application server is monitoring some threads. We are creating lot of threads, right from the public static void main, which is a parent thread. So try to limit the number of threads which is being created in an application server. Like in case of Tomcat, in the conf folder we have server.xml file. We can always see the maximum number of threads created in a thread pool. Max threads is a variable in Tomcat. We can limit it. We can say max threads equal to say 1000. There is no definite value, but it depends on our scenario, our requirements. we can also tune the connection timeout parameter in any web or application server. Like in case of Tomcat, we have a server.xml connection timeout. We can set it. So ensure that your server is well configured to meet the expected number of incoming requests. It depends. Suppose I'm designing a banking application and I know that there will be high volume of incoming requests per day. So accordingly, I have to tune my application server. I have to increase its capacity. I have to do some capacity planning. So try to minimize the logging. See, in case of Tomcat, like we have server.xml file where we can set debug equal to 0. So don't try to unnecessarily use the debug mode in the Tomcat. It degrades the performance. Try to minimize the logging. There is one more thing, like we can set reloadable equal to false. What happens that in Tomcat server.xml file, same can be applied to other application servers. We have a tag called context path equal to your application name. So in that, make reloadable equal to false. Otherwise, what happens that for whenever you do changes in your web application, Tomcat constantly tries to poll for it. It tries to constantly look whether there is any change in your jar file, whether there is any change in your class file. Now, what will happen? Every day you will not change your application, but Tomcat will constantly try to poll for the changes happening in your web applications, class file or jars. So unnecessarily, it is a waste of time. So try to set reloadable equal to false, and so that for all the application contexts, try to set reloadable equal to false in your application server, so that unnecessarily your application is not reloaded every time. So this is some of the things. Sometimes while designing a J2EE application, like we unnecessarily introduce a security layer. See, it depends on the need basis. We might need an LDAP layer, we might need a security layer, but if I'm designing an application where security is not an issue, it only deals with some static pages and a view type of pages, read-only pages. So there is no chances of hacking, or there is no sensitive data involved. It is not a banking application, small simple application. Then I need not do lot of authentication and authorization and introduce a security layer, because it might degrade the performance. So understand the scope of your application and then try to introduce whatever layers you want. So I think I'm done with the PPT, and I'll wait for some of the questions. And one more thing, like I would like to say at the end of my presentation, that always have a plan in your mind before doing the performance tuning. You cannot say that I will do the performance tuning in the production environment, or before the UAT, or after the UAT phase. You should always understand from the beginning, at the time of project management planning, that what is the scope of your application. It can be a web application, it can be a distributed application, it can be an online application, or a desktop application. But how your application interacts with CPU, how your application interacts with memory, disk, or network resources, you should understand. Suppose I am designing an application which tries to access the internet every 24 hours for different updates. Like I am designing a stock exchange website, I am designing a news website. So in that way, in those cases, I should try to simplify the behavior of my application. I should see if I can do away with unnecessarily internet updates or so on. So, and then try to code it. So it's very important to simplify the behavior of an application by understanding how it is interacting with different entities. Oh, hello. Yeah, yeah. Yeah, tell me. Yeah, hello. See, one thing is about the static and dynamic includes. See, the basic idea is whatever can be resolved at compile time, why to postpone it to runtime resolution? If JVM can resolve something, say a static variable, which can be resolved at compile time, that's why the performance improves. So that's the basic objective. Unnecessarily, we should not postpone something to the runtime if it can be processed by the JVM at compile time. In the same fashion, static include of JSP is faster than dynamic include. See, memory leak in Java see, there is no thumb rule to prevent it. Basically, we can optimize our Java code. We can do a good garbage collection whenever we are using any objects. Like suppose we should not try to use lot of string objects. Try to use string builder or string buffer. The basic idea is whenever we are creating any memory location and storing any value, we should try to flush that memory location after the use. Otherwise, that variable will still be lying in that memory location, and that memory location can never be reclaimed. So by making your objects as null in the finally block in your Java code, at least you can make sure that they are eligible for garbage collection, and the JVM frees up the memory or the heap space. See, subqueries and joins. See, in general, what I have found from the research, like joins are always very expensive. I mean, the number of joins increases. So, in general, it has been found that the number of joins as it increases, it degrades your performance. See, why we normalize or optimize your query? There are simple rules to optimize your SQL query, reduce the number of joins, because otherwise you can always use a subquery. That is always preferable over joins. See, minus XMS and minus XMX. One is for the default or the minimum for the starting memory, and one is the maximum memory, which can be allocated to the server. See, sometimes what happens, like unnecessarily we try to create lot of objects, string objects in the entire application. So it's a better idea to club all the string objects, if possible, in a single enum. Enum is always better for the performance tuning, or you can always club all those string objects into a single string and then try to break it or split it and reuse it. So at least I am creating one single string, string x equal to new string, and whatever is the value, rather than creating small strings at many different places in the program. Because string in general, it has been found, consumes a lot of memory. See, query optimization, see, basically, like there are a lot of rules for optimizing any SQL query. So first thing is you should normalize your database tables. You should write the data, store the data in the tables in such a manner that it is the easiest and most fastest to take out the data. So with the minimum number of table joins, with the minimum complexity. There are always query analyzer in the SQL developer. You can always analyze the query, find out the execution time. If you find that out of my 10 queries, one query is taking a lot of time, then you can try to analyze it, what is happening wrong in that query. Maybe you are using select star. You can only use select the columns which you want to take out. Maybe you can use order by or group by. See, order by and group by, of course, can improve the performance, but it depends on the case. It has been found that if you try to use distinct a lot of times, see, if you don't need, if you know already that your data is unique, why to use distinct? Because distinct may degrade the performance. So there are simple tricks where you can simplify your query and make it more faster. So I'll see some other questions. Most of the questions are repetitive. See, using logging, you should see for performance tuning. What I have encountered, I was working with the Aadhaar application of Government of India, the most prestigious application till date in the history of India, and the most costliest one also, I find. In that, what happened, like one day, like we were facing out of memory problems. The server was crashing. What was happening? There was a large amount of data. We were doing encryption and decryption. So we were trying to encrypt the data and store the encrypted data in a log file. We were using logger.info or logger.debug and copying the data. See, the data size was very high in the encrypted format, and it was blasting because the logger file, we are unnecessarily burdening the server. The server has to maintain the server log. It was eating up all the memory with the JVM heap size of the server. So only log important things which you really want to use or audit it. Better you can audit in the database table rather than using system.out.println or logger.info in the log file. So try to disable the logger.debug feature in the server. Otherwise, what happens when you restart your server, all of you might have seen lot of statements coming when the server starts loading and it gets initialized by the time. So unnecessarily you are seeing all those statements in the console, and even you don't need those statements. So you can always disable the debug mode. You can just use info or warn mode or whatever, it depends on a scenario. See, one thing I will tell you about clustering. See, blindly, like we cannot just use clustering and enable the clustering in any web server or application server. It depends upon your use. Suppose you really have a high volume of incoming requests, and suppose you want to make some changes in the configuration, or you want to deploy your data to the application. You want to update something in the application, and at the same time, you don't want the users to be affected. Suppose today Google engine is making some code changes, but still you are able to see google.com. There is no time that google.com will not work because they have a clustering and load balancing. One server is still running the older version until the new version is set up. So there is no delay. So when you don't want to discontinue your service, and at the same time you want to make some patch updates or something like that, you can use clustering. So there are some questions related to string and string objects, like, see, always remember that immutable objects are lot of memory consuming. So try to avoid them. So I'll see something else I can explain in the question. See, that's why somebody has asked about connection timeout exception. See, many times it happens like my server is not responding. It takes more than 10 seconds. For the first time, my page is loaded. It takes 10 seconds. For the next time, it may take lesser time. So this may happen because the connection timeout exception also you sometimes get because the server is taking a lot of time to respond. Because the server parameters, whatever parameters are there in the server.xml file, they are not configured properly. You are not really using the entire power of your server. So it becomes important to set the maximum thread limit or the thread pool size to enable the caching mechanism in the server. So those features, like, you should tweak in the server.xml file or other files, like, and improve the server capability. Then there is some questions like, see, from one of the questions, I'll tell you something. I've encountered in some of my previous projects, like we had the choice to make whether to use MySQL DB or Oracle DB. See, Oracle DB might be very expensive in the clustered environment, the clustered form. But the MySQL clustered database, it's like open source. I can always use it, and it gives the same performance. So it depends, like, even the choice of database, the choice of design pattern, the choice of framework, the choice of server, everything should be decided at the time of design phase, and then you can decide on performance tuning. If you don't know which application server will best suit your requirement, you choose the wrong application server or the wrong database, then even if you tune it to 1,000 times, it will not give you that result. So first make a right choice and then think about tuning it. So I'll read out the questions. What are the important things that one needs to keep in mind while designing a multi-threaded application? See, there are many things like which you can design, keep in mind. The first most important thing which I feel for a multi-threaded application is you should keep on track of the number of thread creation or monitor the thread creation. There is something called thread pool in the server. You can always configure that thread pool size, that is the maximum number of threads which can be created and cached and kept in a cache or a pool. You cannot keep on creating 10,000 threads. Let's say you can create say 100 threads and try to reuse it in the thread pool. So that becomes very important. There are tools like utility like JConsole, which you can use JConsole and monitor the number of threads which you are creating. The inter-thread process communication, how different threads are communicating to each other, should happen in an effective way. Like you should use notify all whenever it is needed. You can use a semaphore or a shared variable. See, there are multi-threaded applications. Different threads are there. They are talking to each other, but they are sharing some common data. So you can make the data as singleton. You can make the data as static. That is one per class rather than one per instance. So suppose I have a static object. Now all the threads in the multi-threaded application will share that static object. That will improve the performance. Otherwise, what will happen? If I am having the instance object, every thread will have its own instance. One thread will try to update, one thread will try to read at the same time. This will lead to a concurrency issue. So you should use proper synchronization. You should use synchronized singleton pattern and improve the performance. Rohit has asked, like, in which scenario to optimize the heap size and in which to optimize the perm space size. See, it depends on the case to case. The heap contains your objects, okay, and then there is stack, like which contains your say temporary variables or the local instances. So suppose you are creating lot of new objects, you are using lot of new operator, then you need to take care of heap size. In general, by and large, you should always take care of JVM heap size more than the perm space or the perm gen. You should worry more about the heap size, because most of the out of memory exception or connection timeout or connection failure is because of the heap problems, heap issues. Somebody has asked how load balancing can be done in the Tomcat. What about the Apache server? See, of course, like, see, whenever you post any URL in the browser, it always goes to the Apache server. That is the basic fundamental. You might be using Tomcat, but it goes to the Apache first. So, see, for the Tomcat server, you can always specify the load balancing algorithm. So there are files, like there are places where you can specify, okay, you want to use predefined load balancing algorithm, which already people have written it. So you don't have to write anything. You have to specify the, okay, this is the algorithm I want to use for load balancing. One is JK mod algorithm, and there are many others. See, somebody has asked Atul how to decide which application server should we use for our software. See, it depends on case to case. You might not even need an application server. You can do away with a web server. Tomcat and MySQL. Most of the industry websites are running on MySQL, PHP and Tomcat. And they are running very successfully. They are making $1 million business. But you might need an application server if you have a business logic in, say, in Hibernate, a DAO layer. You have a EJB, entity beans. For that you need an application server, because you need there are some properties in the application server like scalability, persistence, which you can use directly. Suppose in the application server you have a container managed persistence. Already these features are there, so when you are using EJB it becomes easy. So it does not matter which application server you are using. but you should tune the application server keeping in mind the capability of your database server and the requirement of your application. Ripple has asked, how can we make sure if one server goes down, then the user session is not lost and goes to the backup server without session data being lost? See, one thing is I can always cache my session data. See, basically, whatever objects I am storing in the session, remember, the best practice is always try to serialize the object. Because see, if you are transferring some information over the network, if you are sharing among different servers, one server is in India, one server is in USA, how the data is passing over the network. So you have some data, you serialize those objects, you store it in a HTTP session, and then you can transfer that session from one server to another server. So you need to make sure that you have the server clustering capability and you have a load balancer. So whenever, suppose your CPU utilization time exceeds say 70%, whenever it becomes more than 70%, the load, some of the load is automatically taken from server 1 to any of the remaining servers which are lying idle. Sometimes you can always cache the data in the browser cache also, like username and password in the local browser cache. So to make sure your session data is not lost, you might want to use some timeout in that. But it is not always a good idea to have a very high timeout. The industry standard is like 30 minutes or say 1 hour maximum. You have seen that you log into an application, say gmail.com. After 1 hour, like if you're not doing anything, it automatically logs out. Or say IRCTC website, Indian Railways. You log in, if you're not performing any, it automatically logs you out. So, because the session is like a 30 minutes timeout. See, what is memory leak in Java, which we've already discussed? Most of the times, the memory leak is because we are not utilizing the JVM heap properly. We are not doing a proper garbage collection. We are not reusing the code. We are using a lot of duplicate code. Suppose in my program, I'm declaring and initializing a variable at different places. I can always declare it as a global variable in one place and reuse it everywhere. So we should try to remove the duplicate code in our program. We should try to optimize. We should try to reduce the cyclomatic complexity. In layman terms, we should try to remove the number of lines or the size of a method. If a method is very large, we can always break it into different methods. In these scenarios, we can control the memory leak because we will know when an object is being initialized, how it is being used, and how it is being garbage collected by making it as null in the finally block. When to use string builder and when to use string. See, it depends on the scenario. Whenever you have a data which is being modified by different threads or different say JSP requests are coming and they are trying to modify a data frequently. In such cases, you should use string buffer or string builder because your data is being constantly modified or frequently being modified. But if your data is being less frequently modified or if it is a static data, then you can use final static string object. See, one of the Sachin has asked, many of the times I get response from many of my colleagues that I should avoid using Hibernate. It's a very heavy framework. And so should I go with Hibernate or should I go with JDBC template? See, it depends on your scenario. Hibernate is a third-party OR mapping tool, object relationship mapping tool. You can always go with a plain JDBC. You can go with a Spring JDBC. You can go with iBatis. See, it depends like on the complexity of your database layer. If your database layer or the DAO layer is, the complexity is very less, you might not even need Hibernate, because your application involves say only 5 tables or 10 tables, and each table has few thousand rows or few hundred rows only. You can just write a plain JDBC code or Spring JDBC class and use it. But if you want to manage lots of tables, if you have an application scenario where for some of the tables are there in Oracle database, some of the tables are lying in MySQL database. At runtime, you want to connect to different databases in different JVMs. Imagine a situation like this. Then you can use Hibernate, because Hibernate has a lot of capabilities, like Hibernate can use L1, L2 caching capabilities. Hibernate has a feature like lazy loading. Suppose you don't want to load the child objects along with the parent. You only want the parent object to be loaded, and on demand you will want to load the child object. Hibernate has those features. So think that, do you really need the features which Hibernate provides, and then go for Hibernate. Else you can go for plain JDBC. Because remember, ultimately the Hibernate queries will be converted into the native SQL queries. So the execution cycle is the same. See, one question is there, how to do the performance tuning in the JSP. See, there are many ways like where we can write a good JSP. First thing is we should try to avoid using scriptlet in JDBC, in JSP, because scriptlets like degrades the performance. Try to use the Java code in the Java itself, in the controller layer or the service layer, not in the JSP. This is one thing. If you don't want to use a session, you can disable the session capability in the JSP. So suppose you want to make a JSP a single threaded, you can enable that thread safe. So many a times we try to improve the performance in the JSP by making it as thread safe. It depends on a case to case. Suppose you are using a servlet, you can make it as thread safe or a single threaded model. Most of the questions are repetitive, and trying to think if anything else, some new question is there. See, one question is, what is the best way to compare the data inside a SQLite database? I'm not very sure what Ashish is trying to ask, but okay. See, the best way to analyze your database is to use a query analyzer. There is something called, I will give you the best solution. There is something called, which I have used, SQL Query Analyzer and SQL Profiler. Using these two, you can know the execution time of your SQL query, and then you can try to optimize the query. You can know, yeah, really my query is taking a lot of time compared to other queries. And then you can reduce the number of joins. You can try to optimize the query. Or even you can rechange the table design. Many times it happens that we have created the index over columns which are not really needed. So we can remove those indexes. So I think I'm done with most of the questions. One person has asked, like, can you please give some examples of optimizing the query? See, more than the query optimization, you should understand how your application is talking to the database server. Suppose many a times it happens that within a single transaction, it may be a Hibernate transaction, just imagine. Within a single Hibernate transaction, same data is being requested multiple times by different people. So instead of making a lot of unique calls to the database, we can always reduce the number of redundant reads by caching the data. So in a single transaction, if some data is being requested multiple times, let's hit the database, cache the data for the first time, and then make it reusable, or make it being shared, share it across different requests. So normally the best practice is whenever there is a static data or a data which is being changed less frequently or infrequently being changed, such type of data you try to cache it. Sometimes we have a bad habit of, like, in a single transactions we are doing reading, updating, deleting. So at every operation, SQL operation, we try to commit. It's a bad idea. Let's do all the operations in a batch and then commit the transaction in the end. This improves the performance. Or even you might not want to use an SQL statement for each of these operations, like insert, delete, update. You can create a batch or a stored procedure and then use it. So you have to understand the scenario that, okay, this is my table. Out of 10 tables, this is these two tables. I am more using it for 80% of the life of my program. So most of the modules are interacting with these two tables out of 10, suppose. So then you have to understand that in these two tables, how to optimize the queries, how to optimize the database, how to write a good stored procedure, how to write a good prepared statement, and so on. Because you cannot optimize all the tables, all the classes in one shot. Because time constraints are there in the production. When a bug comes, you have a limited time to do the performance tuning. You cannot say, I will take the application and I will tune it after 1 month. I'll take 1 month to tune it. So you have to make the right choices where to look for. You can analyze the server logs. You can see what wrong is happening, what is the issue. So I think I'm done with this, and thanks a lot for attending the session, and hopefully some of these tips and tricks you will use